All right, we're going to take a look at a couple more examples. These get a little bit more fun, or tricky maybe, if you prefer. This first one, I'm seeing, okay, it's already in terms of sine and cosine. I'm seeing a Pythagorean identity. I could change sine squared. You know, we know that sine squared plus cosine squared equals 1, so sine squared equals 1 minus cosine squared. I could do that here. And I do see a 1 minus cosine squared here, but since I have a plain sine here, I'm actually not going to do that yet. Maybe that will come into play later. But what I'm thinking is, if I think of sine as my x, then this kind of becomes 2x squared plus x minus 3. And we did it earlier, but I can try that out and see, hey, does this factor? And it does. We need to put the 3 here. The 1 here, was it x minus 1 plus 3? Yeah, that will work out for my middle term. That gives me 3x minus 2x, which is x. Okay, so I'm going to factor partially because that helps me deal with this sine. I could have done Pythagorean theorem. Now, on the bottom, I'm seeing I have cosine squared and sine. I'm also seeing this 1 minus cosine squared. And just through experience, I know that that is a Pythagorean identity. So if you don't, sine squared plus cosine squared equals 1. If I subtract the cosine squared from both sides, I get sine squared equals 1 minus cosine squared. And look up at the chart up above if you prefer. But I see this whole thing can be replaced with sine squared. And so I'm going to go ahead and do this. The numerator, I'm kind of doing a bunch of stuff at once, so let me quick review. I factor this, and so that becomes 2. Instead of x, I'm just going to put sine of x in. Sine of x minus 1. And you see it works out the same. If I take 2 sine x times sine x, that's going to give me 2 sine squared. If I take 2 sine of x times negative 1 and 3 times sine of x, that's going to give me 3 sine x minus 2 sine x, which is just 1 sine of x. I switched to x. I need to be in terms of t here. And then 3 times negative 1 gives me negative 3. Okay, so that's one thing I did, is I factored the numerator. I also used the Pythagorean identity to change this to sine squared of t. Now, in the bottom, I get sine squared of t minus sine of t. Now, at first, that might not seem to be real helpful, but I'm going to notice that I have, using this, kind of another factoring thing going on here. If I think of this as x squared minus x, this denominator, I can factor it as x times x minus 1. And so this denominator becomes x, which is really my sine, times sine t minus 1. Let me talk through that. If I factor a sine out of each term, I get sine of t. There's 1 sine of t left, and here it's just minus 1. If I distribute this in, you see we get sine squared t minus sine t. So I haven't changed the value, I've just rewritten it in a different format. So now if I look at this, this is good, right? Hopefully you're seeing I have multiplication here, so I can cancel, I can divide this out, and then I'm left with 2 sine t plus 3 over sine of t. And that is much simpler than what we started with. Now, if you were to just stop there, I'd probably be okay with it. I do want to show you that when I have a fraction like this, where I have a sum in the numerator and one single term in the denominator, sometimes it can be helpful to split that up. And so I'm going to go ahead and do that. 2 sine of t over sine of t plus 3 over sine of t. Now, sometimes this won't be helpful. Hopefully you're seeing here this is helpful in this case because sine divided by sine is just 1. And so this becomes 2 plus. Now, with trig functions, I can always write things as reciprocals. So this is 3 we can think of this as 1 over sine t. 1 over sine t is a reciprocal. What's the 1 over sine t's reciprocal? It's cosecant t. So I can think of this as 3 cosecant of t. And this is the best answer, the final answer, because it's clearly more simple even than this. Now, there's cases where you might prefer to work with this, and that's fine, but that is really kind of all the way through the best simplifying. So, quick review. Here, I didn't use Pythagorean identity, even though I could have on this, because I decided to factor instead. And then here, I did use the Pythagorean identity, and then I factored the sine of t out, and that allowed me to reduce. From there, I split this fraction up into 2 parts, and then change this to the reciprocal of 1 over sine t, which is cosecant of t. Now, you might be looking at this and thinking, well, how could I do this? I could never do this on my own. I followed it, but how would I know to do that? And it's just practice and seeing examples. Really, you try something, and if it doesn't work, it doesn't work. So if you would have tried to do sine squared t and change that using a Pythagorean identity, go for it. Sometimes it works out, even if it's not the shortest route. But sometimes you'll keep going and it'll get farther and farther and you'll be like, this is not working, it's not helping. And then you just say, scrap it, I'm going to try something else. You go back and you try something else. All right, let's take a look at number 4 here. All right, for number 4, it's just, at first it just seems like there's nothing real helpful. Like, this isn't in terms of sine and cosine, so maybe I should change this into terms of sine and cosine. But even when you do that, like at first it's like, this doesn't seem real helpful. Tangent is sine over cosine. There's nothing real obvious that seems to be jumping out. We can't use Pythagorean identities anywhere. There's not really any factoring. But then it's like, well, maybe we could combine these. What would happen if we get common denominators here? To get common denominators, I need to get this in both denominators. So I'm going to multiply this by cosine x over cosine x, and I'm going to multiply this by 1 plus sine of x. And you're probably not seeing it at this point, but I'm starting to see some good things happening here. In the numerator here, we get cosine squared of x, which I like that because that allows me to use Pythagorean identity. In the denominator, you might be tempted to distribute, and if you did, it wouldn't be the end of the world. But I'm going to leave it this way for now, because I'm hoping something will cancel. And so to cancel, I would rather have multiplication in the denominator. In the numerator here, I'm going to go ahead and distribute. I get sine x. Now, that seems like a contradiction. I just said I'm not going to distribute here because I want something to cancel, but then I'm going ahead and distributing here. The reason is I'm seeing the numerator. I want to try to see what that whole numerator is together and see if anything simplifies first before I cancel. Where the denominator, I can just leave it like this for a step or two. And then if I want to multiply it out later, I can. So I end up with sine x plus sine squared x. Okay, again, I like sine squared because it's part of the Pythagorean identity. And in the denominator, I'm just going to leave it as cosine x times 1 plus sine of x. All right, so we now have common denominators. We can combine these terms. This is a little sloppy. Is this cosine 2x or is it cosine squared x? And so I'll try to write a little neater here. It is cosine of squared of x plus sine of x plus sine squared of x. And I'm getting excited. It's okay if you're not. But I see cosine squared plus sine squared. Do you remember what cosine squared plus sine squared is? It's your Pythagorean theorem. Cosine squared plus sine squared equals 1. And so in the numerator, I can write 1 plus sine x over cosine x times 1 plus sine x. And I bet you're excited now, aren't you? We have the same in the numerator denominator. Some people might be tempted to write cosine x here, but this really is times 1. There's a placeholder in that numerator. Cosine's in the denominator. You can't magically bring it up to the numerator. And 1 over cosine I know is a reciprocal function, and so the final answer then is secant of x. So this is fantastic. Instead of working with this, we get to work with secant of x. And so take a quick look. Key, we changed to sine and cosine. That was really helpful. And then once I change it to sine and cosine here, I then get common denominators. Why? Honestly, because I didn't know what else to do. And I was hoping something would work out. When I started getting cosine squareds and sine squareds, that's a indicator you're on the right track, that might be useful down the road, especially when we put them together and we see that this is going to be 1 using the Pythagorean identity. And then we ended up getting 1 plus sine x, and we knew we were on the right track because those are going to divide out and really reduce. And finally, we get it down to secant of x. So there is a practice worksheet and a practice key. If you would like more explanation on that practice key, shoot me an email. I could probably make another video for that practice key. But just work through these problems, and the more practice you have, the better you'll get at it. One other note, we are not going to hit section 7.2 for the spring of 2020. So spring 2020, we are not going to hit 7.2. All right.